What if an object from another star slipped behind our sun and instead of dimming, flared up and turned bluer than the sun itself? Spacecraft watched a sudden, inexplicable surge of light at perihelion while Earth's telescopes were blind, and what those instruments caught doesn't fit the rulebook. In this video, we'll run through 9 jaw-dropping anomalies that make this visitor one of the strangest things astronomers have ever seen, and why mid-December could change everything. 3i Atlas is not just another comet, it's a genuine interstellar visitor, the 3rd confirmed object we've ever tracked that came from beyond our star's neighborhood. It swept into our system on a hyperbolic trajectory and reached perihelion, its closest point to the Sun, on October 29, 2025. Because of that geometry, it briefly vanished behind the Sun from Earth's perspective, which is usually bad luck for observers. Except this time we had a lucky break. A fleet of solar-facing spacecraft kept watching. That matters because space-based coronagraphs and heliospheric imagers recorded continuous behavior at the exact moment Earth telescopes went dark. In short, we caught an interstellar visitor in the act during the trickiest part of its pass, and what those instruments saw set off alarms across the community. But what happened when it slid behind the Sun was nothing like any comet we've seen before. While 3i Atlas slipped out of sight from Earth, a fleet of solar-facing spacecraft, coronagraphs aboard SOHO, Stereo A, and geostationary sensors like GOES-19 CCR1, kept watching, and what they recorded was startling. The object brightened rapidly at perihelion in a way that ordinary Oort cloud comets don't. Instead of a gentle, predictable glow from sunlight scattering off dust, instruments logged a fast, steep rise in intensity that suggested either a sudden, massive outgassing event or something far stranger altering how the object emitted light. Because those space-based images give us continuous coverage while Earth was blind, astronomers could track the surge in real time, and the pattern simply didn't match typical comet behavior. That unexpected surge raised the first alarm, and then came the color change. Then the color shifted, and not in the way physics usually predicts. Several space coronagraphs reported that 3i Atlas appeared distinctly bluer than the Sun, a measurable change rather than a subtle tint. That's strange because dust and cooler surfaces normally redden scattered sunlight. Blue light usually points to hot, excited gases or very different scattering physics. Scientists are testing explanations: sudden emission from molecules like CO or CO2, atomic lines from vaporized metals, or a dramatic change in particle sizes could make the light bluer. But none of the standard scenarios cleanly match the speed and scale of the shift. In short, the color swing suggests a change in what's producing the light, and that mismatch with expected comet physics is why researchers are still debating what actually happened. If gas explains part of it, some other measurements refuse to line up, and that's where the list of anomalies keeps growing. Once the data came in, scientists realized the color shift was just one piece of a much stranger puzzle. 3i Atlas wasn't following the rules of any natural comet we know. Its trajectory cut almost perfectly along the same flat plane where the planets orbit, a statistical fluke with odds close to 0 for a random interstellar arrival. Then there was the jet that defied physics. Instead of forming a tail pushed away from the Sun, Atlas appeared to eject material toward it, as if something was directing the flow against the solar wind. Spectral data hinted at a metal composition rich in nickel, more like an engineered alloy than the dusty, icy mix of normal comets. It was also exceptionally dry, holding only a fraction of the water seen in typical comets. Even the way its light was polarized, its optical fingerprint didn't match anything on record. Add in the fact that its incoming direction roughly aligns with the source of the mysterious 1977 "wow" signal, and you have a list of coincidences that's hard to dismiss. Yet scientists remain cautious. Anomalies can stack up by chance, and space has a way of surprising us. Still, when probabilities drop below the level of winning the lottery 15 times in a row, researchers start paying attention. With 3i Atlas now emerging from behind the Sun, observatories around the world are preparing for the most intense watch in decades. Hubble and the James Webb Space Telescope are scheduled to lock on during its closest approach on December 19th, 2025, while ground-based telescopes and radio arrays will track its motion and emissions around the clock. Teams are hunting for very specific clues: non-gravitational acceleration that might suggest active thrust, radio signals or repeating patterns that can't be explained by natural plasma, thermal hotspots that could reveal artificial heat, or even small fragments or probes detaching from the main body. Governments and research agencies are even coordinating data sharing in real time, something that rarely happens this fast. Every instrument from radio dishes to optical telescopes will be tuned in to answer a single question. Are these anomalies just misunderstood physics, or evidence of something that was built, not born? Two paths lie ahead, and either one would reshape science. If Third-Eye Atlas turns out to be natural, it means our understanding of comet physics is incomplete. Maybe this is a new class of interstellar object forged in conditions we've never seen. That would rewrite textbooks on planetary formation and chemistry. But if evidence shows even a hint of artificial behavior, a pattern, a pulse, a deliberate motion, it would be the biggest discovery in human history. Scientists stress caution. Extraordinary claims demand extraordinary proof, and every signal must be checked, repeated, and verified. Still, the possibility that this object could reveal new physics, or technology beyond anything we know, keeps researchers glued to their monitors. The next few weeks may determine which story we'll tell: the discovery of a new natural wonder, or our first confirmed sign that we're not alone. Right now, the world is watching Third-Eye Atlas like never before. Every telescope, from orbit to mountaintop, is focused on this mysterious visitor as it moves back into view. In just a few weeks, around December 19th, 2025, we'll finally see it up close again, and the data could confirm what kind of object it truly is. Whether Atlas turns out to be a natural phenomenon that challenges everything we thought we knew about physics, or something far more advanced, this is a moment that will define how we see our place in the universe. Either outcome will change science forever, because if this interstellar traveller can shine brighter and bluer than our own star, then we've only begun to scratch the surface of what's out there. Stay tuned, because history isn't happening in the distant past this time. It's unfolding live, right above our heads, and the next chapter could reveal the biggest discovery humanity has ever made.